So we're going to look at connecting graphs to events. The last section we looked at, we were looking at graphs and the motion in a distance time graph. Here we're just going to expand on that. Not all motion is always just set in one constant line. Sometimes we're changing directions and things like that. So we can use our distance time graphs to illustrate that concept as well. So here we have a multiple segment line graph, and we have someone starting at 2 meters, traveling away, stopping, and then returning. So I'm just going to label these sections 1, 2, and 3, and then we have a section. I'm going to make a little table to describe this. So I'm going to do section. Erase that. Section number 1, number 2, and number 3. And then the speed and the time and the direction. So we can describe it using a little table here. So in section 1, we are traveling from 2 to 8. So we're traveling 1, 2, 3, 4, 5, 6. As a rise, 1, 2, 3, 4, 6 over 4. So our speed is 6 over 4, or 1.5 meters per minute. And that was in our 4 seconds. And we're moving away from the initial position. In this section 2, our speed is 0. It's not moving at all, and that's for, and these are, sorry, in minutes, not seconds, and for 2 minutes. So that's for 2 minutes, and it's stationary. That's meters per minute. It's speed. And then in the final section, we're traveling back towards the starting point. So we have a rise of -8 and a run of 2. So -8 over 2, which is going to give me -4 meters per minute. And so that is over 2 minutes. And that is toward the origin point. So we can describe that, and we can use that table to now write out a little descriptor here. So starting 2 meters away, the object moves at 1.5 meters per minute for 2 seconds, or for 2 minutes, sorry. Clean that up. For 2 minutes. Stops for 2 minutes. And then returns to the base level. In 2 minutes at 4 meters per minute. So that could be a description here of what's going on, and if there was a real world situation we applied that to, we could be a little more descriptive, like moving towards a house or something like that, or a sensor. So we can use that table to kind of organize that and then write out the description there. So again, not all linear graphs need to be just the one line. It could be broken up if the situation calls for it.